So
Yeah, mate, good to go.
this is kind of an introduction to underground mapping. So we provide LiDAR data and photogrammetric data to our clients in areas that they wouldn't normally see. We're an industrial service provider for the most part. We go into mines, surface plants, and their other sort of infrastructure. We don't really do residential or commercial too much. It's pretty much heavy industry. We have a variety of equipment that we're able to deploy. We have very good relationships with Flyability, Emescent, Boston Dynamics, Skydio, and RMUS. It gives us a broad range of things that we can bring to our clients to give them insight on the problems that they're having. The company is about 5 years old, started through pure passion for wanting to help and being able to access these sites that people just can't see into, and to be able to save people from having to make the hard decision of whether or not they should go in to look at something. And along with that, because of our experience and because of some of the situations that we've had to overcome and some of the challenges that we've had to endure, it's gained us the opportunity to be involved with several accomplishments. We can't really go to the Guinness book for some of this stuff, but within our community and the mining community is very greatly recognized. I personally hold what I would challenge anybody to be the highest indoor GPS denied flight. I went 980 feet straight up a smokestack, starting at 200 feet elevation. I also hold the greatest or the deepest flight, 9,500 feet underground at a base metal mine just north of Sudbury. We also had this Spot robot dog. We partnered or have a good communication with Boston Dynamics and allowed us to bring that to clients and see where that might fit into their operation. There's a lot of opportunities to send robotics or automated tools instead of people, which is very important. So everything we do is beyond line of sight. Typically, we'll go up several meters, tens of meters, 100 meters from where we are, which is challenging for communications and that sort of stuff. But the environment is also hostile. Ore passes, shafts, ventilation raises, main egresses or secondary egresses, as well as Alamax, which is like a cage that miners would enter. It kind of goes horizontal and then goes to vertical up into a sort of shaft that they're actively working on. These aren't easy places. It's military grade or better, I would say, in some of these environments. It's jagged rocks, it's sharp, it's hot, it's foggy, it's dusty, it's full of gas at certain spots. So the equipment needs to work. But we are able to provide digital twinning and rapid scene capture. So in events, mine events, or emergencies where we can provide valuable data to a situation that's going on, we will. So we go in there with our equipment and we show them what they can measure, what their tolerances are, and counts of things maybe that are on the ground, which would be previously inaccessible to people. It's dangerous and stupid and illegal to go into some of these spots. It's actively sloughing off falls of ground per se, dusty, gassy, foggy, smoky, whatever. It's not worth sending a person in. So we have multiple large-scale mining clients that we work with. Most of the major players, if not all of the major players in the mining industry, we have visited one or all of their sites within Ontario. And we're able to use custom-built rigs to protect our video and LiDAR equipment. It's expensive and sensitive equipment that we need to send into these places. You can consider it like sending it to the moon as well, because it's not somewhere you can go and fix it easily. It's deployed thousands of feet down or out or up or different situations for different applications. But we're able to provide wireless video, telemetry, and control over 2,000 feet. And we operate within the site guidelines. So that's RF site guidelines and as well as safety site guidelines. We can't just show up with whatever we feel like built out of my garage. It has to be safe and it has to work. Oops. Yep. Sorry. Lost my place here. So we were the first ones to bring the Boston Dynamics Spot underground. As far as I know, nobody's been able to do demos like this with large mining clients in hostile conditions. Like we're talking 17% grade, loose rocks, large piles, large boulders, and we test it. It may or may not work in some of those situations. I cannot explain more than that, but that's where we test it. We were an early adopter to the Emerson Hover Map program, which is, the hover map's amazing. It's like magic. It turns underground spaces or full GPS denied spaces into a 3D model easily, quickly, and pretty much on whatever piece of equipment we want to throw it on. We're not worried about banging it or bumping it or throwing its calibration off. It's a very good SLAM-based mobile LiDAR unit that we're happy to be using. Honestly, it's really, really good, and I feel like it's one of the best in the world at the moment. We're also an early adopter of the Elios program, which gives us some insight onto what's coming down the pipe, if you would. We've had opportunities to beta test some of their hardware. We've had opportunities to be able to repair it and get training right from them. They're amazing people to work with, and their E2 gets into places that we just wouldn't be able to see otherwise. It blows people out of the water. The amount of lighting on it, the range you get out of it, it's a really good little drone. It pretty much fits into anywhere we want to send it. It's up to the task, we'll say. So some of the stuff we do with the Elios is high resolution video. Some people just want to see what's going on, what's happening within the scene, where you couldn't send somebody to go look per se. But it also does photogrammetry. We can take the video from it and turn it into a 3D model. We take that 3D model and scan it or scale it, to the hover map model so that it gives us the proper orientation and that we can register it into known and existing control points that are within the mine. That high density point cloud turns it almost into like a video game. So people can experience the whole scenario, the whole scene, the whole stope without actually having to leave their desk or going underground. And we can turn that into a mesh model, which is shared with the client, whatever format they want, whatever software they use, we can provide that to fit in to MineGrid, as well as volumetrics, stockpiles, that sort of thing, quick and easy scans and change detection. So if there's something moving underground and they want to know about it, we can tell them. Some stopes grow on their own, we'll say. Things slough off, rocks move. They're not always supported once you start blasting. So they want to know that information. As well, with the Skydio, we can do some really cool surface modeling. We're very fortunate to be part of the enterprise level of this. And we've paid for the license and the training, and it's well worth it, in my opinion. A really cool little drone, just zips around. So now it kind of comes to the self-serving part. So we are looking for people that have ideas or projects or things they might want to prototype and collaborate on in a real world environment. We can take that piece of equipment and use it and abuse it and tell you what's wrong with it. But we can't fix it in the field, right? Like, it's got to work. So like I said before, you can consider it like sending it to the moon. There's no way of getting this thing back if something happens, or fixing it if something gets broken. If we lose video, if we lose any sort of telemetry link, it's no good. So, which really, if anybody has communication experience, telecom experience, long distance wired networking, stuff that, you know, might be on your mind that we could discuss, we're definitely interested. Any sort of RF experience within a tunnel environment, around corners, within water, fog, that sort of stuff that would typically be a problem. If somebody has a solution, we're definitely keen on that sort of stuff, as well as automation or robotics, ways to control things, ground-based, whatever, you know, whatever might interest you, or you might think you have a spot for underground. So you can get a hold of us at info@uasinc.ca as our general email, just for like our catch-all. But the best way to see what we're doing, like I can't give it all to you in a 15 or 20 minute slideshow, is just get a hold of us on LinkedIn. You'll see some of the data sets, you'll see the models, you'll see what we provide to clients, and the kind of environments we work in. There's really a lot of good examples on there. So, and as well, you can email me directly. I'll answer you, and we can discuss some stuff if you have questions or follow-up questions, whatever might be going on. But yeah, definitely here for whoever wants to listen.
So I had a question you were kind of asking at the end, like, you know, what's the kind of product roadmap? I mean, it seems like you guys have got this really great niche. It's like, you know, kind of leading the space and industry. Love the fact you guys are kind of working with Boston Dynamics and the Robo Dogs and stuff. Where can this kind of technology and product, how can it further develop? What other kind of use cases are you seeing specifically with your mining clients?
The sky's the limit. Like things that could autonomously drive or pull, that can hold heavy weights. We're talking multiple, like hundreds of pounds, if not into the tons, that drive autonomously. Mines are continuously to go deeper, right? Which means people may not be able to get into those spots. It's too hot or too dangerous. So there's more and more autonomy that's being incorporated into underground. It's not the traditional jackleg blasting, what pickaxe sort of what people might think about underground anymore. There's a lot of technology involved, and there's a lot of ways to shape that's coming down the pipe.
Yeah, cool. So when you said kind of some bloke with a pick, I mean I know nothing of the industry, mate, aside from what you've shared. I mean, is there I know Musk has got his boring company where it's just kind of boring holes through. Is there an opportunity for you guys to kind of get into like autonomous like drone drilling, like kind of is that something that you know, taking core samples and stuff like that?
No, those pieces of equipment are extreme duty, we'll say. They're large pieces of metal that need to drive through rock, but they need supplementary equipment, you know, bits, rods, different things, tools, even water, right? Whatever may be required on the job site, there's ways to navigate underground autonomously. And mining clients are starting to understand more about the autonomy and what's involved.
Nice one. Thanks, mate. All right, let's jump to some questions. We've got question here from Frank. Frank's put his hand up and said, question mark not. It's a bit of a naive question. Not sure about this, but let's do it. There's no silly questions here, Frank. Let's dive right in. Frank has asked, how is communication with the drone maintained underground when you don't have line of sight?
It's kind of a two-part question. So some drones, if you get too far away, you just lose communication. Or if you fly through something that it would obstruct the RF signal, again, you just lose communication. And that is a very big risk for certain hardware that may not have autonomy built on. So the Emerson hover map allows me to set waypoints. Excuse me. So if I lose drone link, it continues its mission and comes back to me.
Nice one.
Yeah.
And I think that that actually piggybacks on to the next question here from Ali. Ali has said, can we use Skydio underground? What happens if the robot loses connection? Does it drive back safe to the base automatically?
So Skydio cannot be used underground. It's based on light. So it needs to have a well-lit environment because it's just a series of cameras that are looking for an object. So we use the Helios underground. It's got 30,000 lumens of lighting on board, which gives us more than enough to provide a photogrammetric model, as well as high definition video to our clients. And the Emerson Hover Map uses AL2. So it's waypoint mapping and GPS denied environments. I'm allowed to see a 3D model on my screen in low resolution and then actively set and edit waypoints as it's flying within the environment. That's based on Wi-Fi. So even if I lose the Wi-Fi, the drone continues the missions without having communication to the tablet, and it also continues missions without having control or command from the transmitter, the sentence controller. And it just comes back to home. It's crazy. It's like magic.
Wait.